we are asked to calculate maximum bending moment and maximum bending stress. Look at these two. These two confuse students a lot, but this video will help you to differentiate between these two. For this is simply supported beam with UDL of 12 kN per meter, and this point will have roller support and this point will have pin support. We have been given the cross section of this beam to be this, height 40 cm and this 12 cm. So first of all, let's calculate the maximum bending moment. But in structural element, before you apply any formula, you must first of all understand the structural element which you are dealing with, as most persons tend to interchange formulas. Let's quickly solve this. The maximum bending moment. In this case, this is the formula we're going to use. Where this stands for the load, this for the span, and this is a constant. So what is the load? The load is this multiplied by the span is what? 8 meter. So let's take the square of this. We have this over 8. So let's punch out this in our calculator. We have 96 kilonewton per meter. Sorry. We have 96 kilonewton meter. Please take note, this is bending moment. This eventually becomes the maximum bending moment for this element. 96 kilonewton meter. So let's proceed to number 2. Number 2, I asked to calculate the maximum bending stress. The maximum bending stress, before you can calculate maximum bending stress for this element, you must first of all be able to calculate or know your area moment of inertia and also know your maximum perpendicular distance from this center to this point, to the outer edge, from this point to this point of this cross section of area of this beam. So let's first of all find our area moment of inertia. Area moment of inertia is given by this formula, I equal to this over 12. So this eventually, this B becomes 12, the breadth of this beam. Here it becomes the height of the beam over this. So let's proceed. 40 square multiplied by 12 divided by 12, we have 6400 cm to the power of 4. So this becomes our I, area moment of inertia. So having gotten your area moment of inertia, the next thing for you to do is to get your C, as the maximum distance between this center to this point. That it is called the maximum perpendicular distance from the center to the outer edge. So this will give us, this is the formula to calculate this. The height of the beam divided by 2. What is the height of the beam? The height of the beam is 40 over 2. So this is giving us 20 cm. So having gotten these two, the knowledge of the maximum bending moment is important, but because these values are in cm, cm to the power of 4, you also convert this kilonewton meter to Newton cm. So how do we do this conversion? Let's convert this maximum bending moment value. We have 96 kilonewton meter. For you to convert this to Newton meter, you have to multiply this by 1000. Now it is in Newton meter. For you to convert this in Newton meter to Newton cm, you have to multiply by 100. Let's point this in our calculator. We have 9600 Newton cm. So this is the formula to calculate the maximum bending stress. where M stand for what? Maximum bending moment. C stand for what? The perpendicular distance from the center to the outer edge, and R is area moment of inertia. So we have gotten this to be this. Let's put inside the formula. Our C is what? 20. Our I is what? 4. So let's punch out this. We have 3000 Newton per cm square. So this is the value for maximum bending stress, but remember that maximum bending stress, the unit is always in either in PA or in MPa or in PSI. So let's convert this to MPa for the final answer. So if you are converting this to MPa, you have to divide this by 100. So we eventually have 30 MPa. This eventually becomes the value for the maximum bending stress.